Okay, so at your desk, you should have our notes from yesterday along with your periodic table from yesterday. Now, we stopped reading on the back of page 1 at the bottom here. For homework, I told you to read chemical properties of chemical families. So we're going to read that together and make sure that you understand it. We're going to go over your homework. So, a chemical property is a property of a substance that determines how it reacts with another substance. Okay, if you remember from 5th grade, we had physical properties and chemical properties. Chemical properties is how it's going to react, how it's going to have a chemical reaction. So it says here, burning is a chemical reaction. That means flammability, the ability to burn or the ability to catch fire, is an example of a chemical property. They gave you an example. Now, what are we going to be talking about? The property that we're going to be discussing is reactivity. Reactivity is another important chemical property. It describes how likely an element is to form bonds with other elements. Forming bonds means making ions, just like we took notes last week on what is an ion and how does it form. They give away electrons. They take electrons. Okay, that is a chemical reaction. It's a chemical change. Reactivity is the chemical property. So if I'm wanting to know if a specific element is reactive, what am I going to look at? It tells me here that these chemical bonds between atoms are formed by the atom's electrons. Specifically, they are formed by the electrons in the outermost energy level, which are called valence electrons. So if I want to know if an atom is reactive or not, I'm going to look at their number of valence electrons. The number and arrangement of valence electrons help scientists predict how atoms will combine with other atoms to form compounds. Because all the elements in a group have the same number of valence electrons, remember the groups go up and down, they have the same number of valence electrons, that will tell me how reactive they are. These groups have similar chemical properties or similar reactivity. That's what we're going to be going over and learning for the next week and a half now. On the next page, it goes into more depth about the reactivity of the different elements on the periodic table. It says the most reactive metals are the alkali metals in group 1. The alkali metals in group 1, yesterday y'all told me they have 1 valence electron because they're in group 1. That would be these metals right here. Okay? They are the most reactive. So what I want you to do is I want you to get a pencil or pen or whatever you want to use. Come to your periodic table, and down here next to group 1, we're going to write most reactive metals. You can just join class now. Just keep it and join class. Okay? Most reactive metals. So that means group 1, all of these here are the most reactive because they have 1 valence electron. Okay, 1 valence electron, an example would be lithium here, number 3. So it would have 3 protons in its nucleus. How many electrons on the first energy level? 2. And how many on this last energy level? 1 valence electron. So what's it going to do with this electron? If it's going to react with another element, what's it going to try to do? Give it away, right? Wants to give it away. It wants to get rid of it because atoms are happy when their levels are full. They don't like having just 1 and a bunch of empty holes. So we call this alkali metals in group 1, we call them the givers. You should be writing what I'm writing. They give away their electrons. Now the rest of paragraph 1 tells us about a specific element that doesn't really follow the rules. It says, although hydrogen is the first element and seems to be in group 1, it is not an alkali metal. Hydrogen is a distinctive element whose properties do not closely resemble those of any group of elements. So back on your periodic table, let's look at hydrogen. They said it is in group 1, but it's not like any of these other elements. For one, is hydrogen a metal? No, what is hydrogen?
Gas.
Gas. So go ahead and put a G in that top corner. It is a gas. And if it's not a metal, then it must be a non-metal. So I'm going to take the color here that I did non-metal, and I'm going to shade hydrogen to match it, to match all my non-metals over there. In fact, in some periodic tables, they actually take hydrogen and they put it like up here, where it's not connected to the rest of the periodic table, because it's so different. So just remember that hydrogen is in group 1 here, but it's not a metal, it's a non-metal, and it's a gas. So it's a little different than the rest of the ones there in group 1. Okay, back on your notes, let's read about group 2, the alkaline earth metals. They are very reactive. Okay, group 1 was very reactive. It says group 2 is very active. But look, it says they are slightly less reactive and harder than group 1 metals. The reactivity of both the alkali and alkaline earth metals increases with the increasing atomic number. So basically, group 2, how many valence electrons will they have? Group 2 means they're going to have 2 valence electrons. So if I was going to draw someone at a group 2, I'm going to draw beryllium, this first one. And I'm going to draw it down here where I have more space. Beryllium would have 4 protons and 4 electrons. So I'm going to have 2 in my first level, and how many in my second level? 2. Can they easily give away an electron? They would have to give away 2 of them, right? So they are also called givers. They give away those 2. Now the reason they say they're not as reactive as group 1 is because let's say that you had 2 kittens and you had to get rid of them because your mom didn't want you to keep them. You know how sometimes your cat has kittens and they don't want to keep them, but you don't know what to do with them? If you had to give away 2 kittens, would that be harder than giving away 1 kitten? Yeah, probably so. Okay? You could easily find someone who wants a kitten, but to find 2 people who want a kitten is harder. Same thing with valence electrons here. Okay? This one can easily get rid of 1, but to find somebody who needs 2 is a little bit harder. It's not that hard though. It's still pretty easy. So that's why they're still reactive. They're just not as reactive as group 1. Okay, then it says here groups 3 through 12 include the transition metals. Transition metals are often form the colored ions. Ions were what we studied when we talked about trading and giving away electrons. It says recall that an ion is an atom that has a positive or negative charge. Ions form when atoms gain or lose electrons. Halogens are nonmetals in group 17. The halogens are the most reactive nonmetals. So halogens are the most reactive nonmetals. So let's go back over here.